Good morning and welcome. I'm glad you guys could make it. What we're going to talk about today is a little bit of our success story at Corning. I'll give you some background on Corning. Corning was founded in 1851. Our headquarters is in Corning, New York, and we have approximately 50,000 employees worldwide. As of 2023, our revenue was $12.6 billion. Corning Incorporated is one of the world's leading innovators of material science. For 170 years, Corning has applied its unparalleled expertise in glass science, ceramic science, and optical physics to develop products and processes that have transformed industries and enhanced people's lives. Corning's mission is another 170 years of innovation and independence, but we never take our eyes off the big picture. Our ultimate goal is a world that's better because of our efforts, a world with cleaner air, healthier lives, richer entertainment experiences, and more efficient communication. So we'll just walk you guys through some of our market segments and the industries that we help shape. In the display space, Corning helped create the LCD industry by inventing a process for making thin, flat glass with exceptional stability and unparalleled surface quality. In the optical communication space, we are a leading manufacturer in fiber optic communication systems, solutioning voice, data, video, network applications worldwide. In the automotive space, in the early 1970s, Corning developed an economical, high-performance cellular ceramic substrate that is now the standard for catalytic converters in vehicles worldwide. In the mobile consumer electronics space, we're pioneering glass that's thin, lightweight, damage-resistant, and responsive to touch. Corning is helping transform the way people use their smartphones. Corning continues its legacy of innovation with market-leading covered glass, as well as glass and optics for semiconductor products that enhance device performance. As a leading developer manufacturer in the life science space and global supplier of laboratory products for over 100 years, Corning's life science segment works with researchers and drug manufacturers seeking to increase efficiencies and reduce costs and compress timelines. And what we're really going to talk about today is the success story that we had with our Databricks environment and our AtScale implementation. A little bit of a history lesson. Over the last 30 years, we started off with data marts in the 80s and 90s. The industry moved to enterprise data warehouse solutions as data expanded and capabilities increased. In the 2010s, we moved to platforms like Data Lake on Hadoop and others. We didn't invest heavily in this technology, but others did. And now today we have cloud data in the 2020s that provides us separate storage and compute for scale. This is a representation of our ERP landscape. ERP is Enterprise Resource Planning. Corning has two major perspectives. It's the Enterprise Resource Planning perspective and the manufacturing perspective. This is a representation of our systems. We have a lot of complexity in those platforms, and they developed over a 20 or 30 year period. In terms of our current state for data, very confusing to look at it in this regard, but if you look at this, we have an ability to create application reports based on ERP platform systems. We're very focused on Excel technology, which is what, 20-year-old technology. Our future state, we're going to move outside of that platform and advance in a number of different ways. Two parts, operational data stores. Our current platforms didn't have the ability to support reporting data, so we had to build a set of operational data stores to support that. ERP could not support query volume. Supports and ad hoc inter-day reporting were available. Our usage is hourly, daily, weekly, monthly, and we have a large Excel orientation, as we mentioned earlier. Our reporting data marts are daily copies of our ERP for management reporting systems. They provide division-wide views of our ERP data with other data and metrics, as well as KPIs. Our usage is weekly, monthly, quarterly, yearly, and our primary consumer is Power BI and OLAP Excel pivot reports. So this sounds like a lot of old technology because it is. And then the complexity starts to go up as you look at how we look at division level data reporting and other capabilities across the company. A number of initiatives have been going on for the last couple of years. One of them is an ERP transformation process. In that first set of slides, there was about 30 to 35 ERP platform instances across the company in different divisions. And there's an initiative that went on for about 3 or 4 years now that we've been looking at cutting that number down to a much smaller number and then coalescing around S/4HANA as our future state ERP platform. So the enterprise platform is foundational backbone for covering majority of our functionality for our ERP systems and reporting platforms. It has to take into account legacy scope, so we have to provide functionality that must be addressed for business continuity. And it also has to support future capabilities. So we have advanced warehousing, we have advanced logistics, CRM has to be advanced as well, and a product lifecycle management and other capabilities have to be available within that platform. So as we went through a process of understanding how we're going to migrate off of our legacy platforms that look something like this into a more strategic environment, we realized that there's going to be a lot of impact to our reporting systems and platforms. And this is a simple example of just one of those division implementations. CET is our division that stores data in a data warehouse. Inventory data moves into the warehouse. In our SAP deployment implementation number 1, it would break the data that's flowing from the ERP platforms into those system reporting platforms. Same thing would happen with a second SAP implementation and a third and a fourth. In this environment, we really had 3 options. Option number 1 is to do nothing, and that really wasn't an option. Option 2 is to backfeed from our legacy platforms into the new platform technologies, but that obviously preserves existing reporting during transition, but it's very time-consuming, expensive. Some data won't fit backwards, so we have, like say if we have a PeopleSoft system and an SAP system, even though there's similar data, very difficult to make those things align. Each division would have the same exercise, so we wouldn't have to do this once. We'd have to do this multiple times per division. It requires a strategic investment for us on the enterprise data platform side, and that was our choice to go with that approach. That approach also aligns with an overall data strategy, common approach for all divisions, and it integrates data from other systems. And that's one of the core tenets that we had to create an ability around, was to integrate data from external partners, internal partners, and systems that don't communicate well today. It requires, as I said, strategic investment. Effort to provide division-wide reporting during transition is one of the cons of that approach. It's going to require significant change management. And it also may require us defining standards for reporting cataloging, which we have addressed. So as we started down this road and developed this process, I'm just going to highlight a few of the guiding principles. Some of them are, let's say, principle number 2, do reporting in the first system that has all the data needed. And this was the ability to actually not take data out of all platforms and move it into the strategic platform, but if that current platform supports reporting, then we don't move the data. And then second piece, guiding principle 4, only move data for reporting when systems cannot support the requirements or to add value. So in other words, we're not just going to move all our historical data to the new platform. And we're not going to enrich data unless it needs to be enriched in the new platform. Stitching data together across different systems should be done in the centralized enterprise data platform as a primary tenet. Business rules should be done at the data layer and not not in the report layer, so that we can use a concept around reusability. That was one of the core issues that we're having with our systems today, where very difficult to reuse a lot of the logic that we have in our reporting capabilities because it's not reusable. The last one, let natural disruption drive replatforming. That one is critical. It's not replatform from platforming's sake, but it's going to have a disruptive capability where if we see disruption in the marketplace, in the business, then that is what drives our replatforming activities. So as we went through the process and we had a lot of different stakeholders, we had to start to communicate to the stakeholders to get them to understand where it is the enterprise data platform actually sat in the architecture. This is a pretty standard architecture around looking at a hierarchy in terms of strategic versus non-strategic data assets. At the top of the hierarchy, obviously, is advanced analytics and strategy. At the bottom of the hierarchy, we have operational and transactional reporting capabilities, and we positioned the enterprise data platform at pretty much at the top of the pyramid. And then we defined each layer for the business so they clearly understood where we were going. The other piece of this was we defined a set of boundaries. We wanted to also have the business and the technical teams to understand the difference between transactional reporting, management reporting, and analytics reporting, because there's a huge difference, as I'm sure a lot of you are aware, that it's a very different perspective on how we deal with data. The EDP aligned very well to business intelligence and analytics reporting, advanced analytics reporting, but we wanted to stay away from really doing the traditional transactional reporting in the traditional platforms, because those platforms already have a set of report capabilities that are in place. And unless they need to be changed or modified, or unless we need to add additional data to those capabilities, then we will leave those in the source systems. Back to the history of processing. So in the 80s and 90s, data marts kind of were the thing that everybody was doing at a corporate level. As the volume of data and the processing power and the ability to collect data went up, corporations started to move to EDW for reporting to reduce the load on the primary systems. And then, of course, in 2010, I'm sure as everybody's aware, Hadoop came out. MapReduce was the answer, but we didn't get on that bandwagon, and we had limited investment in EDW in the 2000s. So what that allowed us to do was to focus on how do we get our legacy platform data out of our primary data marts and get it into the cloud, using the principles we talked about a little bit earlier. In that process, we built a defined data architecture. This is a very high-level architecture. We have a lot more detail around this. This is what I can share with the team today. Data sources on the left side, data delivery on the right. You guys involved in data know how this works. We aligned to the Databricks architecture, the medallion architecture, and also aligned to the capabilities within Databricks around data science, analytics, and in the future, generative AI. We also built a whole platform around moving the data from the sources into the data lake and prepping it and getting it in the right format in the bronze level. Because as you guys probably already know, when we move data to Databricks, I can't just move S3 objects. I have to reformat those and get them into Delta formatted objects and ready for consumption. And then on the right side, we'll hook up to our current reporting platform capabilities. So there was a couple ways we were looking at this. Financial transformation, ERP transformation hadn't been ongoing for a while. So we had a huge initiative in the company to move toward that direction. Those two were kind of combined together. During COVID, there was a lot of supply chain disruption, and we have over 100 plants around the world. So our management team wanted us to be able to understand through our data systems what is the impact of that supply chain disruption. And so during the process we were building the data platform, we had what I consider to be the first use of the data platform, which essentially was inventory insights. That was critical because it was very successful. We were able to bring the data together, land it in Databricks, build reporting capabilities, advanced analytics capabilities around that, and understand our inventory data in a way we never could before. That was one. Two, because it was successful, it allowed us to go back and get more money to do additional work on the platform. Because if we weren't successful, we wouldn't be able to fund the next piece of the work. We also aligned with a concept called Manufacturing 4.0, which is an industry standard model for digitizing data in manufacturing companies. And it aligns to how we wanted to do data in our business. We also partnered with a number of our divisions. CLS was one of them. At the same time, they were building out a set of initiatives, and I'll go through that real quick. So, like I said, Corning Life Sciences was one of our divisions. They were doing a transformation around the same time we were spinning up our data lake. So their objective, their future landscape needed to achieve the following. It needed to meet customer demands faster to achieve competitive advantage. Employees had to be confident in the products and services they deliver to customers. It wasn't just the products, it was the data around the products. We had to drive consistency and scalability through governance and organizational alignment, which we did somewhat, but it was difficult to do based on the technology platforms that we had available to us. And we had to quickly respond to market challenges and external forces. This initiative started around 2021, about a year and a half after we started the build out of both the Databricks environment and the reporting platform and the pipelines. And what they did, they established the fact that they need as well a data lake to sustain them in this program. We partnered with them, and they began to use the Databricks environment that we stood up a year earlier. This is another diagram that shows the current system landscape for one of our divisions, CLS. And it's a complex environment. And most large corporations today have complex environments, difficult to get their data off those environments into and transition to something much more flexible. CLS developed a COE, and we had partners within that COE that worked with us directly for each of these roles. Change management, PMO. We worked more directly with data management and analytics than we have in any other program. And then business process and risk management. I said earlier about the manufacturing 4.0 strategy and framework. The framework essentially is a industry standard framework that recognizes that a lot of manufacturing companies are having the same basic business problem, which is the stuff on the left. There's a lot of systems that aren't able to integrate well together so you can compare notes essentially in the data. So by moving into the strategic platform, CLS and Corning were able to do things that we never could in the past. We were now able to integrate data, we're now able to share data, and start to build out a strategy. The other positive about this was that CLS was really the second use pattern for our data lake. So now we have inventory management and then CLS. Once you have two, you start to get more divisional usage and more requests to do exactly what they've done successfully. The other piece of this for CLS was they also needed not just to do the data platform, but they had to create a whole different intake process around centralizing user experience, designed around core operations, standardizing external and internal performance understandings, and then a whole piece around training communication, which is foundational to become more proactive using our data. These things should have been done in the past. With the strategic program, we were able to fund them and actually get them done as well for CLS. This slide talks a lot about, I think, what most people understand to be the problem with data wrangling today. So we looked at two major consumers, our sales teams and our BI and data science teams. And we created a measurement that said, okay, in the sales team, how much work is being done in insights? And what we found was performing silo analysis, taking time away from their core responsibility, was taking up about 80% of what they do day to day, and only 20% was actually creating value. And when we looked at data science team, the 100% might be a little overkill in terms of the measurement, but essentially it's an 80-20 there as well, where data wrangling was taking so much time for the data science teams that they didn't have an enablement engine that they could request data move at point A to point B. Our data pipelines now do that in an automated fashion. And then, of course, on the right-hand side, the ability to kind of remeasure and rebalance those capabilities between information and insights was kind of critical to us. So at the same time, we changed the way we align our capabilities and who we hire for to align to that. Two big things we found out during the process. One is on the information access side, individual users performing siloed analysis takes time away from the core responsibilities. A centralized analytics tool, on the other hand, to surface insights that are broadly beneficial, gives time back to those professionals. One of the other things, we'll go back to the current state. You kind of can see these Rubik's cubes sitting on top of some of these data marts. So those are our OLAP cubes that we have custom built based on what we have in our custom legacy platform. And one of the problem statement reads like this: end user feedback indicated that slice and dice through Excel was a critical data analysis capability. Adoption of Databricks would be hindered without providing parity with existing data marts. And Excel can connect to Databricks, but doesn't support seamless multidimensional analysis. So that was our problem statement. There's a lot more to that. Bring it down to 3 main points. This is kind of where we're at. So to that end, what we did was we did an exploration of some of the competitive technology companies. We took a look at, we first took a look at Databricks SQL Warehouse. And at the time when we measured this, it didn't really meet the need. And we are aware that over time, Databricks has actually added capability and they continue to do so. One of those was Unity Catalog. When we started this 5 years ago, Unity Catalog wasn't at the level of maturity it is today. We had to bring in a company called Privacyera to do that for us. So now we've gone back to aligning ourselves to Unity Catalog. And then of course, additional capabilities around that, building new pipelines, making it easier for people to get access to data, data cataloging, all that came along with the strategy. So in terms of OLAP, we started to look at another vendor called AtScale. So AtScale's premise is they deliver a leading universal semantic layer for enterprise data teams to manage and scale analytics infrastructure for business intelligence, Gen AI, and data applications. 3 claims to fame: they don't move data off cloud platforms. They leverage existing BI and data infrastructure, and they integrate openly with Data Fabric in managing analytics, metadata, and governance. So I'll just forward here a little bit. So the before and after. So before, we were using multiple pipelines to get data from systems, and we weren't centralized around the data platform. So if I think about the left side where I got Databricks, Databricks is becoming where we're storing all of our data for reuse. Load once, use many. In our current environment, we were loading many and using once. So after that, AtScale comes in the center, we build a semantic layer around it, and we're able to do OLAP, and we're also able to centralize our data points in the data warehouse. So where does it sit in the Databricks architecture? It sits beside the gold layer, or if you're looking at it the other way, it sits on top of the gold layer. AtScale, in some ways, is a virtualization layer that sits there. There's no physicalization, but it actually does create generated aggregations for us. And we looked at it in terms of small interactive, large interactive, and system engineering use cases. We then looked at our architecture and said, where does it fit? This is a fairly simplistic view of where it fits, obviously the same as the prior architecture. But we wanted our business people to clearly understand where a new technology it belongs. And although simple in terms of these diagrams, we actually have 2 or 3 layers of this. One is the one that we present to the business team, one that we present to the business/technical teams, and one that we present to the technical teams. Technical teams are super technical with all infrastructure and technical capabilities assigned. The business/technical teams will have something kind of in between this. This is what we present to management, so they're clearly focused on where this belongs in our architecture. The value of a universal semantic layer, I think, as everybody knows, it's an ability to create something once, virtualize it, and allow our business intelligence tools to get access to that so we don't have to redo the work. In our current environment, we're doing this multiple times. We're doing an OLAP cube for Tableau. We potentially could do something for Excel. We're doing something for Power BI. Sometimes we reuse some of that, but there's a lot of work that goes into this, and we needed to create a virtualization semantic layer for the architecture. So in the AtScale POC, we built a semantic model of orders of shipment data. And then we deployed Excel workbooks to connect directly to AtScale semantic. Still back to this Excel concept, but it's going to take us many years to kind of decouple from Excel in terms of how the business looks at the way they want to manage data reporting. And then we deployed workbooks to 20 power users, which are essentially our toughest critics. And so what we found was semantic development was straightforward. AtScale had a robust UI for designing metrics and measures. No need for calculation period. And user feedback has been positive. And comments like, I feel like our old data warehouse cubes are available for us now. Caveat on this, we're fairly new with AtScale, so it's a piece of our architecture that's been newly created. We have a lot more work to do, but what we've actually done is we try to take a look at a new technology and capability, align that to what we already have in our architecture, figure out where it fits. And we typically run POCs before we actually implement a lot of this. But if I look at the alignment model here now, AtScale is aligned with the top layer, which is essentially business users, developing ad hoc transactional reporting. So it will be that layer that they can use their BI tools to access. And in the future, we're going to look at how we can use AtScale for other capabilities in terms of divisional standard transaction reporting, descriptive, and then potentially how we use it for predictive and descriptive analytics. That's kind of a third on our list because data science typically are looking at things differently. They want to write things in Python. They want to do their own thing. So AtScale next steps for us. CLS, Corning Life Science Division, we are expanding user base of initial model to 100 plus users. We're building additional models for customer sales, rebates, contracts, and pricing. Our second division, CET, Environmental Tech, is developing a customer product and order semantic in support of first app deployment. And then our finance organization is building a replacement for manufacturing cost cubes. Short list, but it's baby steps to get to a greater good. All right, guys, well, that's great. Thanks you guys for coming.